All right, class, in this video, I'll be doing the first example from section 15.4. It says evaluate the definite integral. And to do that, we're going to have to apply the fundamental theorem of calculus, which I have stated at the top in blue. And before we can apply the fundamental theorem of calculus, we're going to have to ask the question, is x squared plus 2x minus 1 continuous on the interval -2 to 3? And that is a resounding yes. X squared plus 2x minus 1 is continuous because it is a polynomial. The domain of a polynomial is all real numbers. So, from now we can apply the fundamental theorem of calculus. And it says to evaluate the definite integral, we're going to have to find a capital F of x, which is an antiderivative of the lowercase f of x, and then evaluate the antiderivative at b and at a, and then subtract those two values. X squared plus 2x minus 1, that is your lowercase f of x. The antiderivative of the function is x cubed divided by 3 plus x squared minus x. And we're going to want to evaluate this function from -2 to 3. The x cubed divided by 3 plus x squared minus x, that is capital F of x. That is the antiderivative of lowercase f of x. Now, we are going to evaluate the antiderivative, capital F of x, at 3. And that looks like this. And after some arithmetic, that value is 15. Next, we're going to evaluate the antiderivative at -2. And this value is 10/3. Finally, we're going to subtract capital F of 3 minus capital F of -2. That's equal to 15 minus 10/3. And if you rewrite that, that is 45/3 minus 10/3. So the final value is 35/3. So the value of this this definite integral is 35/3. But what does this value represent? Well, what I've done over here to the right is I provided a graph of f of x. And what I'm going to do is I'm going to shade this portion red. Actually, I'll do it again, but I'll make the shading a little smaller. I'm going to shade this portion below the x-axis in red, and I'm going to shade this portion above the x-axis in green. So the shading in red, the graph is below the x-axis, so the area is negative. The green shade, the graph is above the x-axis, so the area is positive. So the area shaded in red plus the area shaded in green is gonna be the number that you found when you evaluated the definite integral.